Okay, so now we're going to pick up talking more about human activities that damage the environment. And the first one we're going to talk about has to do with introducing non-native species into an environment where they don't belong. There's two terms to know with these. You have your exotic species and your invasive species. So your exotic species are any species that are introduced by human activity, whether that was intentional or not intentional. If humans introduce it, it is an exotic species. An exotic species then becomes an invasive species when that introduced species has some sort of harmful impact on the environment or other organisms. An example of this with an exotic species we have is the monk parakeet. So this was imported to the United States as a lot of pets for people. However, several of them escaped, and ultimately they didn't have any competitors or any issues in this environment that wasn't used to them. So they kind of ran rampant around cities and urban areas and built giant nests on utility poles, which created a huge nuisance for humans. And like I mentioned, invasive species can be introduced either intentionally, so on purpose, or unintentionally. However, there's a couple characteristics, regardless of how they get into their environment, that make them unique. So when the species are introduced, they don't have any natural predators or pathogens because the environment that they are moved to didn't give rise to them. So there's no natural checks and balances in terms of natural selection to limit their population size. So since the parakeet doesn't have any natural predators in the United States because it doesn't normally belong there, there's nothing to keep the population from growing. And there's no diseases yet to then similarly affect that parakeet. The other problem with introducing species is that the prey or any sort of native plants and animals don't have any defense against those species. So if an invasive species could potentially eat them, and they don't have any defenses because, again, they're not used to having that animal in their environment, so they don't know how to contend with it. And to give you some examples of some accidental introductions of invasive species, first one is the brown tree snake, and these were introduced accidentally into the island of Guam. And the issue with these was that the native bird population on the island had never had to contend with this predator, this tree snake. So ultimately, they didn't have any defense mechanisms, as we learned in the last chapter, to evade predation. So the snakes ultimately had a lot of free meals on them. Second example we have is with the purple loosestrife, and this was introduced to the U.S. as a garden plant. However, as with many invasive plants, the plants don't have any natural competitors, so they usually can outgrow a lot of the native plants. So most of the grasses and flowering plants in the United States got choked out by this purple loosestrife. And then we have zebra mussels, which were introduced into the Great Lakes in the north. And ultimately, this invasive species caused a lot of problems for humans because they ended up clogging a lot of the water pipes for businesses and homes, ultimately causing a lot of financial damage. Then another example we have for this time that's intentional. So we brought a species here, or brought a species somewhere for the purpose of conservation, was with the cane toad. So in Australia, one of the big issues they had with their agricultural system is they had a lot of pests in terms of insects and other small critters eating their crops. So to combat this, they decided to bring a species that wasn't native to Australia, called the cane toad, that would act as a natural predator for those pests. However, they didn't foresee that ultimately the cane toads didn't have any natural predators. And ultimately, when they brought them over, they did eat some of the pests. They created a population explosion and basically drove out a lot of the snakes, lizards, birds, and other species just because they didn't have any checks or balances to limit their population size. They just had a huge population explosion. And ultimately, even today, cane toads are a big nuisance for a lot of Australian citizens. So, the next human activity we're going to talk about has to do with acid rain and how it harms forests and aquatic ecosystems. So we know that when we burn fossil fuels, we release gases like carbon dioxide into the atmosphere, but that's not the only gas that we release. We release two other ones as well. This one right here, sulfur dioxide, SO2, and then this one as well, nitrogen dioxide, NO2. And by themselves, they're not inherently harmful, but when they mix with water, ultimately they form sulfuric acid and nitric acid. And those acids mix with the cloud formation, and when it rains, those acids are rained down to whatever ecosystem that they happen to be above. This, of course, creates problems because you have acid raining from the sky, which creates a lot of destruction. Ultimately, the acid rain can actually kill plants directly because you have the acid actually literally eating away the tissue of the plant, destroying them from the outside. But also, having this acid rain makes the soil in these sorts of ecosystems very acidic, so it makes it hard for new plants to then grow and recover from this setback. Additionally, you can indirectly kill animals with acid rain because you can contaminate their water supply and make it very acidic. So when they drink this water that their body system can't handle, and ultimately they end up dying. So the third human activity we're going to talk about is all about greenhouse gases with climate change. So climate change, obviously a hot button issue, but in terms of the actual science behind it, the idea is that the average temperature of the Earth is increasing because we have a lot of increase in greenhouse gas emissions from burning fossil fuels, which is heating up the Earth. And this happens because of what's called the greenhouse effect. And the idea here is that when the sun shines down and has its rays hit the Earth, ultimately some of it gets absorbed, plants for photosynthesis, some of the heat gets absorbed by the ground, However, some of that light energy actually gets reflected and escapes the Earth's atmosphere, goes back into space. But some of that energy actually gets trapped by the greenhouse gases in the atmosphere and then stays in the Earth. That is ultimately what allows the Earth to have any sort of temperature at all, because of this effect. And by itself, the effect is not actually harmful. However, when you continue to add more greenhouse gases repeatedly over years and years and years, the more greenhouse gases you have in the atmosphere means the more heat you can trap. So because humans are constantly having industry and burning fossil fuels for energy usage, we have a lot of greenhouse gases in the atmosphere, so we're trapping a lot more heat, and we're heating up the planet to a much higher amount and at a much faster rate than would naturally occur. Ultimately, this is going to cause a lot of issues, both biologically and for humans in turn. So, for biological systems, we're going to have some changes with plants and animals. So things like your trees and your flowers are going to start blooming earlier and at higher latitudes. They're going to start moving closer to the poles as the poles are colder as you move up or down. Additionally, migratory birds are going to arrive at summer ranges earlier because the temperature is going to be colder earlier because it'll be way too long. The summer is going to be much hotter than it used to be. Same idea with butterflies and other birds. You're going to have them expanding their ranges northward or more towards the pole. And by itself, it doesn't seem like these attributes are harmful, that we're having earlier blooms or things are just happening earlier. But the problem is that when earlier has to keep being bumped back to earlier and earlier and earlier, because that's when it gets mildly warm. What happens when the Earth gets too hot? You don't have a cold period and a warm period, you just have a consistently hot period. Those trees and flowers aren't going to be able to bloom because they don't have the right conditions to do so. And for things like your migratory birds and butterflies, if they go north and they hit the mountain range, ultimately, when it gets too hot at the mountain range, even from continually increasing temperatures, those birds and those butterflies will have nowhere to go, and they'll eventually just die. Additionally, with the rising global temperatures, you have the poles getting a lot hotter, so you have a lot of this Arctic ice melting and thinning out. So ultimately, you're destroying habitat for Arctic animals, but also because that ice is melting and you're adding more water to the ocean, the overall sea level is rising, which will eventually lead to flooding. And also you have ultimately crop failure from these more extreme conditions. Not only are you having just general hotter temperatures overall, but you're having more extreme weather patterns. So rainy seasons and storms are much more violent and turbulent than they used to be, which can ultimately destroy plants. Additionally, one problem that definitely affects us in terms of climate change is infectious diseases with the warmth and temperature. So insects thrive very well in hot temperatures. So things like mosquitoes and ticks, which we know carry diseases. So things like malaria from mosquitoes or Lyme disease for ticks. are going to basically explode and produce a lot more instances of disease as we have warmer temperatures. However, the problem with all of these, the problem is that, of course, all of these things are bad. We want to reverse them as soon as possible. But global warming is a very difficult issue to tackle because it's such a large problem. It's not just the United States problem. It's not just a Europe problem or an Asia problem. It's an everybody problem. And ultimately, in order to combat this global problem, we have to come together as a global community to be able to solve it. And there are certain initiatives in play, but we want to keep incentivizing countries to do all of these things in order to reduce emissions. First one is ultimately to reduce fossil fuel consumption, so burning less fossil fuels and finding new ways to power things and find new ways to power things and new energy sources. Ultimately, you want to reduce deforestation and replant forests because plants ultimately take CO2 out of the air, reduce the amount of greenhouse emissions you have because of photosynthesis. So plants are very helpful with that. But if we cut more of them down, we're then allowing more CO2 to exist in the atmosphere. Additionally, looking at new technologies, new ways to get carbon dioxide out of the air. One of them is called carbon sequestration, excuse me. Can't talk today. And the idea behind carbon sequestration is that we could potentially put some of that carbon underground out of the atmosphere. We could take it from the atmosphere and store it in the earth below. So ultimately it's not in the atmosphere, allowing for more heat to be trapped. Okay, so the fourth example, or fourth activity we have is deforestation with the rainforest, which is causing not only species loss, but more carbon to be released. So because we're at the equator and we have the highest intensity of sunlight, these are the highest ecosystems that have the highest level of productivity. So as you see in the diagram here, in yellow, that was all the tropical rainforest that existed before we had all the human influence. So it extended through much of Africa, through a lot more of South America and Central America, as well as India and China and East Asia. However, because of deforestation and getting rid of a lot of this habitat for human development, ultimately we are reduced to what's left in the green. So a lot less than we used to. And because of this, we have several impacts. The first one, we have a lot less biodiversity because we cut down all of these tropical plants in these hotspots. We got rid of a lot of the plant life, which then supports a lot of the biodiversity for herbivores and primary consumers, secondary consumers, etc. Additionally, as I mentioned with greenhouse gases, by removing more plants, you then remove the ability to take carbon dioxide out of the atmosphere for photosynthesis, and more of it ultimately gets accumulated. And because of this, you have an acceleration of climate change because you're not pulling carbon out of the atmosphere, and then you're also adding more from burning fossil fuels. So you're just speeding things up by chopping plants down. So how do we ultimately solve the problem of deforestation? So again, it's going to be a global problem as such, it's a US problem or a Europe problem or other countries' problems. We have to come together and basically implement several strategies. So protecting these very diverse areas, identifying these global hotspots is key in order to know that we have to protect them. Additionally, addressing poverty seems not necessarily like a direct correlation, but in terms of villages and settlements and other areas that are right near these forests that may be using those environments for resources, we have to address those areas and show them new ways to develop and assist them with their ultimately development. Because if they're continuing to use that resource, we're next to them and cut them down without replication, without information about the replications, that's going to cause an issue. Ultimately, looking at different sources of food and energy development as well, in terms of how can we get food or sources of energy without cutting down trees or removing as many trees. Reducing population growth, which, as we talked about in the previous chapter, ultimately will help with the decreasing the amount of consumption of resources. And then finally, education. So educating people about why these ecosystems are important. Why do we need them? Not just for diversity's sake, but also for combating global climate change. So with the emission of greenhouse gases in the atmosphere, we do have global warming, but we have another atmospheric problem that is in recovery, but it's important to talk about. And that has to do with the ozone layer depletion. So this is a separate issue from greenhouse gases. A lot of students will get confused and think that these issues are one and the same. They're not. So ozone depletion has to do with the amount of ozone in the atmosphere. Ozone is a chemical. It's got 3 oxygen atoms. So you know oxygen is O2, ozone is O3. The reason ozone is important is that it's in the atmosphere to protect us from the sun. So we get the sun for sunlight, which helps us for making vitamin D and producing, and for photosynthesis. But if we have too much of that sunlight, too much of that radiation, that can cause issues. And the ozone acts as a barrier, it's sort of an invisible natural barrier for the sunlight. And we have, unfortunately, large holes of ozone that are in the north and south pole areas. So if you look on this diagram from the late 1970s, we have this blue wispy pattern right here. That is a very weak concentration of ozone above one of the poles. We did have this issue identified, and ultimately we started to remedy it, and we see that there is a replenishing of ozone all the way to 2014 when this data was taken. The reason we want the ozone is because if we deplete the ozone and we have more radiation from the sun coming in, we have what's called increased UVB intensity. So we talked about ultraviolet light causing damage to DNA with mutations. And we know that mutations in DNA ultimately lead to cancer. So when you have more radiation from less ozone, you could have more instances of cancer, which of course is detrimental to your health. Additionally, you can cause a lot of ecosystem damage by having too much UVB radiation. This radiation can basically damage plant tissue and make it so those plants can't actually utilize photosynthesis. So you can't grow crops or grow trees to replenish the environment or to sustain agriculture. And we found from studies that the major culprit for ozone depletion was what was called CFCs, or CFTs, excuse me. And CFC stands for chlorofluorocarbon. What that means is that it's a carbon substance that has chlorine and fluorine in it. Some of the substances from the 70s and 80s that use these are your hairspray, as well as a lot of your styrofoam products. So hairspray is an aerosol. When it gets into the atmosphere, it then goes up into high above the earth. It can damage the ozone. And then when you have things like your styrofoam products burned as part of trash removal, that can also release those chemicals into the atmosphere as well. So by reducing those CFCs, we can allow the ozone to replenish itself. So those are all the big human-caused problems that we have in the environment. And when we're talking about conservation, we have a limited number of resources to combat the damage we caused, unfortunately. We have to make some difficult decisions about how are we going to utilize our limited resources to protect what we have left. So we may have to make choices between something like an animal that's more charismatic, like this tortoise, or between something like soil bacteria. In this example, does it make sense to protect something that is more symbolic and more charismatic in terms of representing nature? Or is it more important to protect something that may not be as charismatic, may not be something people care about, but what if this soil bacteria is very important for maintaining an ecosystem? What if we need that bacteria to maintain soil and thus plant life, and that could be the linchpin for an environment, versus a tortoise, which is important, but the environment could survive without it. Ideally, we would like to be able to save everything, but unfortunately, we will have to make hard choices about what we can and can't protect. And there's a couple different approaches to protecting biodiversity overall, and the approaches are a species approach or a habitat approach. And there's no right or wrong answer per se. It's just two different methods about how to go about this. So in terms of the preserving species method, the idea is to target specific species that we believe are very important to an ecosystem and, of course, protect them from going extinct. Because as we know, when an animal or plant goes extinct, we don't get it back. It's gone forever. And the United States has done this through the Endangered Species Act, which identifies species that are about to go extinct and tries to step in and mitigate this by producing more of the species through shelters or refuges, stepping in from protecting them against predators, or stepping in with habitat remediation projects. The second way we have is preserving habitats, the second approach. And the idea behind that is that we want to not just target a specific species, we want to target an entire environment, entire habitat that a bunch of different animals or plants inhabit. The idea behind this is that we're taking the broad approach. So we're trying to protect the whole habitat, and by doing that, we're hoping to protect all the species that live in that habitat. We haven't necessarily identified a species that is endangered or not endangered. We're just we're casting a giant net to see if we can protect everything. And by doing this, we would hope that we would then prevent species from falling into the endangered category and then going extinct. And for the habitat approach, we have possible landscape conservation projects. So things like your national parks in the United States are a great example of trying to conserve habitat. So things like Yellowstone Park and Yosemite, both parks made over 100 years ago in order to protect the land and ultimately all the species that inhabit it. Additionally, you have what's called the World Wildlife Fund. It's the initiative called the Global 200, and these are basically identifying 200 plus environments throughout the entire globe that we should be protecting because they have a lot of biodiversity in them. So with protecting landscapes and making preserves, we of course have your things like your national parks and these initiatives, but in terms of looking at things at a more local level, we can design preserves or modify nature to support animals and plants as well. And the idea behind designing these nature preserves is to have a couple of key features. So the first one for designing nature preserves is they need to be larger and undivided. So if you had, for example, 100 acres of land, of forest, we'll say, and in example 1, you had them in a nice giant block, and in example 2, you had 100 acres of the forest separated into a bunch of small little blocks. You're going to want the larger block that has less surface area and is less divided so you can keep the ecosystem all together. You don't want it broken apart. Additionally, you're going to want to try and have it circular instead of linear. That will make the space have more volume, and thus the animals will be able to utilize it better. If it's linear, you'll have a lot of what's called edge effects. So that means you'll have more of the habitat exposed to the outside. So for example, a forest, if you had the forest edge next to a grassy field, you potentially have more instances of predation, more instances of parasitism of disease, which can ultimately hurt the preserve. Next, you're going to have what's called corridors. So if you can't have an environment that's large and undivided, maybe it is smaller and slightly broken up, you're going to want to have these little strips of land called corridors that will connect your patches of land from one area to another. This will allow your animals to move within the habitat and not have to leave it, and again, be exposed to things like predation, disease, etc. And lastly, in your preserves, you want to create what's called a buffer zone. And these are just areas that limit the amount of human activity. So most nature preserves, the way it's done, that the buffer zone will prevent humans from being able to go in the nature preserve, but be able to go next to it via a road or a sidewalk or whatever. Then, in terms of talking about preserving species within these nature preserves, a couple of different vocab terms to know about approaching conserving species. So the first one is called your flagship species. When we take the flagship species approach, what we do is we're identifying a species that's very charismatic, that has a lot of public support to rally behind. Usually flagship species are very successful because people like these species. They are cute or cuddly or cool, and people want to make sure that species exists for a really long time. Perfect example are pandas, because everyone thinks pandas are cute and amazing. So because people like pandas, they want to rally behind it and help preserve them. So this is an example of a flagship species, has broad, wide appeal. Next, we have keystone species, which we talked about at the end of the last chapter. And remember, keystone species are species that have a really disproportionate effect on the biodiversity. So if we remove that species, it's going to have a huge ripple effect and potentially cause an ecosystem to collapse. So we can potentially use a keystone species approach for conservation as well. Next, we have what's called an indicator species. And the idea behind an indicator species is that the presence of this species indicates, as the name implies, some sort of ecosystem quality by its existence. So example I have here, as you see on this tree, there's some lichen, and lichen are very good indicators of air quality. So if you have lichen in a forest environment, that means the air quality in that habitat is very good. So indicator species are a good way to test the health of an ecosystem. And lastly, we have what's called the umbrella species. And umbrella species are basically arbitrary species that we select for the purpose of conservation. So they may be a keystone species, they may be an indicator species, but for some important reason, we have selected them for our conservation efforts. And again, this is a case-by-case basis, and it's very arbitrarily assigned. So umbrella species can also include one of these other groups of species. But basically the idea is that we take the research we have on the species and we believe that the umbrella species will have some sort of trickle-down effect into the ecosystem. All right, the last thing to talk about in terms of additional ways to save biodiversity are through things like captive breeding programs. So when species are endangered, if they're about to go extinct, we can use a breeding program to take them out of the environment, make sure they have food, water, can reproduce, get that population number back up to a healthy amount, and then reintroduce them into an environment. We also have habitat restoration, in which we utilize a field of study called restoration ecology, where we're taking principles of ecology itself in terms of how ecosystems work, in terms of how land management works, and we're using them to restore some sort of degraded habitat from either urbanization or some sort of disaster, but ultimately we're trying to get that land back up to a functioning state so it can support animals and plants. Then lastly, we have zoos and botanical gardens. So as a potential source of conservation, we can use zoos to protect endangered species as well as endangered plants as well. And that will do it for chapter 18.